Welcome back. So we are analyzing circuits with the combination of series and parallel networks. So let's solve another example to find the equivalent resistance between point A and B. Okay. So we will follow the same approach like we did in the previous example, that we can label the nodes. So like this is A, this is B. Let's label this C. Let's label this as D. Let's label this as E. Okay. Then we will start from the end of the circuit. So if we start from the end of the circuit, what we can see here, so basically this 3K and 6K, okay, they are sharing only one node, or same current will flow through both of them. So it means they are in series. So 3 and 6 series, that will be basically what? 9 kilo. So it means if I just redraw this circuit here, okay, so I have this 18K, I have this 6K here, okay, and so at this point, I have 10K. This was the node E. Okay, this was the node C. This is A and this is B. So this 9, 6 and 3 become 9. So that will be basically connected between where? Between C and E. So here I can put basically one resistor of 9 kilo ohm, okay, which is basically series of these two. Now if you look at this circuit, we can see that this 9K and 8K, they are sharing two nodes, okay, this one C and the other one E, right? So once certain branch is shared two nodes, so it means they will be in parallel. So it means we can say that basically 18K is parallel with the 9K. So when 18K is parallel with 9K, okay, how we can calculate? 1 over 18 plus 1 over 9 inverse. So this will become 6K, okay? Or we can also get the other way, like we can multiply these two values, 18 times 9, and then divided with their sum. Okay, so this will also give me 6K. What does this mean? This means these two branches can be replaced, okay, with a resistor, okay, of how much value? 6K. And that will come where? Between node C and node E. Okay, this is 6K and this is node A. Okay, so between C and E, we'll have a resistor of 6K. What else we have here? We have a resistor of 10K here, okay, connected at E, and this is our point B. Now if you look at this circuit, what we can notice here, like 6K sharing only one node with the 6K series, right? And this sharing only one node with this one series. Or in other words, basically same current will flow through all these components. So once the same current flow through all the components, resistive branches of your circuit, means they are in series. Now if you are looking from this end, we can say that resistance between points A and B, it will be series. Series means their sum. So 6 plus 6 plus 12. Okay, so that will be basically equal to what? 22 kilo, right? So this is how basically we can analyze a circuit with the parallel and series combination of resistors. Thank you so much.